Hi and welcome to this video where we discuss about build packs and explore how they enable building containers without the need for a Dockerfile. If you are looking for ways to streamline container creation or curious about how to skip writing complex Docker files, then you are in the right place. And don't forget to subscribe to my channel for more tech bites. Alright, let's talk about containers. They have transformed how we develop and ship apps portable, efficient, and deployment friendly. But creating Docker files, not so fun, right? Docker made containerization accessible, but it also turned us into part-time DevOps engineers tangled up in endless configurations from dependencies to environment variables. It can get complex fast. Wouldn't it be great if we could skip that step altogether? Cloud Native Buildpacks are tools that transform your application source code into container images ready to run on any cloud platform. Essentially, they handle all the work behind the scenes to create reliable production-ready images without a Docker file. This means Buildpacks simplify containerization by focusing on your application, making it easier to deploy consistently across different environments. So what exactly are cloud-native Buildpacks? They are a powerful tool that abstracts away the need for a Docker file. Buildpacks automatically detect the best options for your application, creating the container image from your source code and export it as an OCI-compliant image. In other words, they take care of the entire containerization process, making it faster and simpler to go from code to container without all the manual steps. We are going to cover the essentials like installing pack CLI, buildpack commands, building images with buildpack, and finally, we will look at the difference between Dockerfile versus buildpack. Let's look at some of the important buildpack commands. With the pack builder suggest feature, buildpacks take things a step further by recommending the best base container image for your project. It scans your code and suggests an ideal image to match your application needs. This way, you are not guessing which base image to use for your code. Buildpacks provide guidance to make sure your container is optimized for your code. In the screen, you can see how the pack builder suggest command has given the suggested builders for building our image. The pack build command is central to creating your container image with buildpacks. It's structured with a few key flags. First, there's the build flag, followed by the name you choose for your container image. Here is web app. Then the -- builder flag specifies which base image to use. And finally, the -- path flag points to where your application code is located. Additionally, you can pass -- env to pass any environment variables. Altogether, this command builds your container image efficiently as per your project. The pack inspect image command is used to get detailed information about your container image. This includes specifics like its layers, metadata, and build information. It's a quick way to inspect what's inside your image and verify that everything is set up as expected. The base rebase command is a powerful feature that allows you to update the base image of your containerized application without having to rebuild the entire image. This can save time and resources, ensuring your app stays up to date with the latest base image improvements while maintaining the integrity of your existing setup. The pack build -- cache - image command is designed to create a new container image while leveraging a cached image. This approach speeds up the build process by reusing layers from previous builds, reducing the time it takes to compile your application. Let's go through the key phases of Buildpacks. First is Analyze phase. This phase reads metadata from any previously built image and checks access to the OCI registry, making sure we can write the image we are about to build. Second is Detect phase. Here Buildpacks are selected through a process called /bin/detect, which also produces a build plan tailored to your app's needs. Third is Restore phase. This phase restores layers, metadata, and any cached layers from a previous image, helping to optimize the build. Fourth is Build phase. Next, the build packs are executed using /bin/build, where your app's components are compiled and packaged. Finally, the export phase. It creates an image and the layers are cached, preparing your application for deployment. Together, these phases streamline the entire containerization process from start to finish. Now let's start with some demo. In the demo, we are going to create a simple Node.js web app and run it on our local, and also we will see how we can build and push an image to Artifactory. But before that, let's install Buildpack. As I am using Mac for this demo, so I will be using Brew. For any other OS related, you can view the official Buildpack website for the installation instructions. So for me, the command is brew install Buildpack /tab/pack. Once this is installed, then we will start with the actual Buildpack build. Now the installation is done. Let me clear the window. Now I am going to run pack builder suggest command. So if you see right now I am inside the folder where my source code is. You can see the package.json and server.js. So I'm going to run the pack builder suggest command, and what it will do, it will first analyze my source code, and then based upon that it will share me the base images that can be used as a builder for my pack build command, right? So as you can see, I am going to choose this one, the GCR one, and I'm going to copy this. Let me clear the window. And now I am going to run pack build command. So it will be pack build, then the app name or the image name, right? And -- builder. And here I am going to paste the GCR image that I have be using for base image that we have received from the previous pack builder suggest command, right? And additionally, I am passing an environment variable with -- command, and I'm passing node environment as production, right? And then I am going to pass the path, so with the option -- path. So since I'm inside directory, project directory, so I've just passed dot, right? And now it's basically downloading the base image. This step is similar to the build that we see in Docker as well, right? So let this build complete. So if you notice, we can see the phases that we have discussed. Start with analyzing, detecting, then restoring, then building. So once the building is done, then it will be exporting, all right? So finally we will get the Docker image. Let's wait for that. Okay, perfect. Our base image web app is created now. Let me clear the window and let's see Docker images. So if you can see, web app is created. So now with the help of Docker, let's run this image and let's see if it is working or not. So for that, I'm going to use docker run -p to publish port 8080 : and our container port is 3000. Right, let me copy the image name, web app. Perfect. So our container is getting started and it started listening on port 3000. Let's verify this on the browser. I'm opening my browser Safari here. Let's check for localhost and see, we can see welcome to Nandi Tech Bytes. Next, I'm going to show you how to create and push the image to an Artifactory. So for that, I'm going to modify the previous command and I have added -- publish at the end. And here I'm going to name the image as per my Docker Hub Artifactory. So it's DevOps 091 slash, my repository name is 93 bytes colon version 2 is the tag I'm giving. And let's run this. So what it will do, the pack build will basically build my image and then it will push to the Docker Hub repository. A quick note here, if you have not established the connection with your Docker Hub Artifactory from your CLI, then this command won't be able to push the image to the Artifactory. For my case, it is already done. I have already used Docker login, and in the analyze phase, backbuild has already confirmed that it has checked the authentication and the image is not there. So it's trying to build and push the image now. Meanwhile, please don't forget to subscribe to the channel for latest content on cloud and DevOps. Looks like the image is pushed. Let me verify in the Docker Hub. So as you can see, the V2 image is showing here, right? And if you go inside, you will be able to see the layers. Now let's discuss the differences between Dockerfile and Buildpacks. When comparing Buildpacks and Dockerfiles, we see some key differences. Buildpacks offer automation, making the containerization process easier and more streamlined, while Dockerfiles provide the flexibility to customize every aspect of your container. In terms of ease of use, Buildpacks simplify the process. No prior Docker knowledge is required. Conversely, Dockerfiles demand a deeper understanding of Docker to craft the desired configuration. Buildpacks emphasize standardization, ensuring consistent environments, whereas Dockerfiles cater to advanced use cases, giving you the power to tailor your container to your specific needs. Ultimately, the choice between Buildpacks and Dockerfiles depends on your project requirements and expertise. With this, I am concluding this video. Please do like, share and subscribe to the channel. Thank you.